Hi, Doc Revis here. In this video, I will show you how to calculate molarity, moles per liter. So, the concentration of a solution is the amount of the solute present in a given quantity of solution. When that amount is measured in moles per liter, it is called molarity. So molarity is a concentration that contains a given number of moles in a liter. When we measure molarity, we always measure it against liters. So if we're given milliliters, we convert that to liters. If we're given some other quantity, we convert to liters. If we're given grams, we convert the grams to moles. Molarity is defined as moles per liter. Let's use an example of molarity. Moles per liter. A 355 ml soft drink sample contains 0.133 moles of sucrose, which is sugar. What is the molar concentration of sucrose in the beverage? As soon as you see the term molar, you think units. The units are moles per liter. So we set this up. Molarity equals moles per liter. We know that we have 0.133 moles, and we must divide that by liters. However, our given was in milliliters. We therefore perform a unit analysis in the denominator of converting 355 mils to liters by crosshatch 1,000 mils on the bottom per 1 liter. This gives us a molar concentration of 0.375 big M. The big M stands for moles per liter. And we can take the solution now and use it to carry out chemistry. Let's try another example. How many grams of potassium chromate are needed to prepare 250 mils of a 2.16 molar solution? By the way, potassium chromate is used as an oxidizing agent in many organic transformations. The first step is to determine the moles of potassium chromate in the 250 mils, or the equivalent in liters is 0.250 of this 2.16 molar solution. So we set up the equation and we start with our given of 0.250 liters of solution. We then crosshatch down using dimensional analysis the liters on the bottom, and we know that we can take liters directly to moles because moles per liter is a recognized conversion factor in chemistry, and therefore we get 0.540 moles of potassium chromate 3,6 figs. We then note that the molar mass of potassium chromate is 294.2 grams per each mole. Therefore, we take the moles and we carry through a dimensional analysis of converting moles to grams as shown, where the moles are on the bottom, grams are on the top, as a standard dimensional analysis using gram per mole as a conversion factor, and we obtain 159 grams of potassium chromate. The process works the same as processes we've used before. Dimensional analysis starting with a given times a conversion factor to the species of interest, following the units, following the standard math steps. How about another example? In this example, a chemist needed 3.81 grams of glucose for a reaction mixture. Calculate the volume in milliliters of a 2.54 molar glucose solution she would need. In this case, we're going to practice this one by using the formulas. The formula for molarity is moles over volume, the volume in liters. We can rearrange this to solve for volume, where we would have volume equals moles over molarity. Therefore, the first step is to find the number of moles. To find the number of moles, we start with the given grams, 3.81 grams of glucose. we do a dimensional analysis, crosshatch bar on the bottom with grams because our given has grams, and whatever the given has, the denominator must have in the very first conversion factor, and we convert grams to moles, and therefore we now have the moles of glucose. We would then plug this into the formula, but note that we must change the molarity concentration to milliliters. Therefore, we have the liters on the bottom, and we do a conversion times 1,000 ml solution per 1 liter of solution, and this will allow this to be converted directly to milliliters. Alternatively, you can solve this in liters and then do the conversion, whichever is easiest, okay? The math to do this, you're familiar with. As long as you follow the math rules in doing these dimensional analysis, you're okay. So you could do this by getting the answers in liters and then converting it to milliliters. Either way is perfectly acceptable, as long as it follows the standard rules of math.